Revision for oscillation. Question number 1. State and explain whether graph 1, 2, and 3 in following figure represents simple harmonic motion. The graph 1 does not show simple harmonic motion since the period does not stay constant as time goes on. So the graph 1 is not simple harmonic motion as the period is not constant. Graph 2 does, since the acceleration is proportional and opposite to the displacement. Straight line graph through the origin with negative gradient. Graph 3 does not, since the amplitude does not stay constant. So the graph 1 has no constant period and graph 3 has no constant amplitude, therefore they are not simple harmonic motion. While graph 2 does, since the acceleration is proportional and opposite to the displacement. Straight line passing through origin with negative gradient. Question number 2. The graph shows displacement of particle from a fixed equilibrium position. A. Use graph to determine the period of the motion. So let's amplify the graph. Since this is cosine graph, the period is from crest to adjacent crest, and that is 0.2 second. B. On a copy of the graph, mark a point where velocity is 0 and label this with the letter Z. The velocity is 0 at any point where displacement is at maximum or minimum points. BII, a point where velocity is positive and has the largest magnitude. We know the velocity max when the displacement is 0, and the gradient of the displacement time graph gives us the velocity. So we have a positive gradient and we also have a positive gradient. Positive gradient gives us positive velocity, and the velocity maximum when the displacement is 0. That's the 2 points. Those 2 points where the velocity is positive and has the largest magnitude. BIII, a point where the acceleration is positive and has the largest magnitude. Since acceleration is proportional to displacement and opposite direction, and acceleration graph is just a reflection of displacement graph. Points where acceleration is positive and has the largest magnitude, those A points. Next question. A graph in the following figure shows the variation with the displacement of the kinetic energy of the particle of mass 0.4 kilogram performing simple harmonic motion at the end of spring. A. Use a graph to determine the total energy of the particle. Total energy is the kinetic energy plus the potential energy. When the kinetic energy is max, 80 millijoule, potential energy is 0. So the total energy is 80 plus 0, which is 80 millijoule. II, the maximum speed of the particle. When the kinetic energy is maximum, velocity maximum. So E max equals to 1/2 times the mass times the maximum velocity squared. So maximum velocity squared equals to 2 times maximum kinetic energy divided by mass. Both sides squared, we get maximum speed equals to root square of 2 times maximum kinetic energy divided by mass. Plug in the values, root square of 2 times 80 millijoule converted to joule, 80 times 10 to minus 3 divided by 0.4. The maximum speed of the particle is 0.63 meter per second. III, the amplitude of the motion. from the displacement, we can see that is 4 centimeter. Last one, the potential energy when the displacement is 2 centimeter. When the displacement is 2, kinetic energy equals to 60 millijoule. As we know, total energy is equals to kinetic energy plus the potential energy. Total energy is 80 millijoule and kinetic energy is 60. So potential energy is going to be 80 minus 60, which is 20 millijoule. B. On a copy of the axis draws a variation with the displacement of the potential energy of the particle. The total energy is equals to 80 and graph is going to be inverted parabola like this. Crossing point has to be 40. When the kinetic energy is 40 millijoule and the potential energy is 40 millijoule, 40 plus 40 gives us 80, the total energy.